For example 7 of 7-6, when you're integrating a problem where you have a square root down below, then you're really looking at a baby right there. Now this is essentially a 5-step process, but the 5th step is just to write out the solution. So let's go to the first step. The first step is to identify the baby. The baby is always u. And because that square root of x is deep within the problem, it's in the denominator, it's involving a radical, then we're going to say that u is the square root of x. Now I really don't want to deal with u like that. I want to change it to u squared. And so when I square u, I will end up with just x. Now I can take the derivative of u squared and the derivative of x, and I will get 2u du equals 1 dx. Once I've done that, I'm going to use that information for step 2. If you look at dx right here, I can replace dx with 2u du. So I put 2u du in the dx position. Now I replace square root of x with u, and I have 1 over u minus 1, 2u du. And that is going to be step 2. Just substitute in. Step 3 involves long division. And the reason why is because I've really got 1 times 2u, and the power of the numerator, which is u to the first, is equal to the power of the denominator. So I'm going to divide u minus 1, the denominator, into 2u. Remember that 2u really is multiplied by 1, so it's the numerator. And when I do, u goes into 2u twice. 2 times u is 2u. 2 times negative 1 is going to be over here, and it's going to be a negative 2, but I put positive because we're subtracting. So now I just do subtraction 2u minus 2u, and then we're going to have 0 minus a negative 2, which is a positive 2. You bring down, your remainder is 2. Now that remainder is going to go on top of what you were using to divide into 2u. So it's now an answer of 2 plus 2 over u minus 1. Now this is similar to the problem we did earlier. I believe it was number 4. So long division is step 3. So now we can take this whole integral and break it into 2 different integrals. Step 4 is to break up each integral. And to break up each integral, I'm going to say the integral of 2 du, and make sure it's du and not dx, because everything is in terms of u, plus, and then we're going to take this answer right here, we're going to take the 2 out and leave it as 1 over u minus 1 du. Now remember, that was originally written as 2 over u minus 1 du. We just pulled out the constant. Now when I'm dealing with 1 over u minus 1 du, that essentially is a form of 1 over x. And the antiderivative of 1 over x is going to be the natural log of x. But u minus 1 is the baby. So if I were to write this part here out even further, if I wanted to, I would have the integral of 1 over u minus 1 times the derivative of u minus 1. And the derivative of u minus 1 is just going to be 1. So I really don't need to show all that work because it's equal to 1. I've got an invisible 1 right here. So now I take the antiderivative of 2, du is going to be 2u, keep the 2 right here. This is going to be a log answer because it's 1 over a baby. It's the natural log of the baby in absolute value plus c. Now if you need, you can see that you can't leave everything in terms of u. It's not a need, it's a have to. You have to replace what u is equal to, go all the way back to your u value right here, square root of x, and plug it in for u there, plug it in for u there, and you have your final answer right there. I want to drop back to example number 6 on the previous page for those who did not get it. We have the integral of this expression right here, the integrand. The first thing I'm going to do is I'm going to identify the baby as 2 minus log of x, and I'm going to raise that to the negative 3 power. Then I'm going to take 1 over x and I'm going to split the fraction, put 1 over x right here. Now the reason I did is because the derivative of the inside is 1 over x. However, the derivative of negative log of x is negative 1 over x, so I have to put a negative here, and I have to put a negative there to balance it. So now I'm going to treat the baby to the -3 power as a power rule integration problem. So I add 1 to -3, I get -2. I divide by -2, or I multiply by -1/2. I already had a negative here, so it's a -1 times a -1/2, which gives me a positive 1/2. Now I have the baby here to the -2 power. Don't forget your plus c. And then when I finish, this is going to be my answer right here. And that's how you do number 6's example and number 7 example of 7.6. Good luck on the homework. If you have any questions, be sure to come and see me.